The thing I love most about STEM is that it flips upside down the learning paradigm for students. Especially in something like mathematics, we often have students answering questions that have been posed to them by the teacher or the textbook. However, STEM reverses that and it actually has students themselves generating questions that mean something to them because they've got a problem that they want to solve. They want to design something, they need to measure something accurately or know how many of something that they need. And so they themselves are the ones coming to me saying, "Sir, we're trying to solve this problem. How do we do it?" And I'll say, "I know exactly the tool for it," and then I can introduce the maths. So I love that it gives them a really strong need for why they're learning what they're learning, and that really helps with the student motivation side of things. There are a few obvious ideas that I think should come to people's mind when they think of mathematics, things like numbers and shapes. But what I deeply love about mathematics, and I hope people think of when they hear the word, is about patterns and underlying relationships. For example, when there's a reality that sort of connects all of these things that seem like they're separated. Now that's really important when we're solving problems because sometimes out in the world, things that seem separate are actually run by the same mathematical principle. And when you understand that principle, you can solve all of the problems no matter how different they look on the surface. So let me give you an example of this. If you have a think about the path that something takes as you throw it under the force of gravity. So if I've got a ball and I throw it to a friend, if I'm playing basketball or something like that, the shape that's familiar to most people, this sort of up and then down shape, it's what mathematicians call a parabola. That's what happens because Earth is pulling that ball down to the center of the Earth, and that's what creates that shape. But gravity makes different shapes. Say, for example, when you think about a comet going around the sun. It actually makes sort of this round kind of shape, and it orbits. It's not a parabola at all. So it feels like those are two distinct realities that don't have that much to do with each other, except for gravity. But there is a single mathematical reality underneath both of those, and it's this cone shape. Now you might think, what does this have to do with anything? And the answer is, if you take a cone like this, and if you slice it at a particular angle, what you'll get is, through the middle there, a parabola type shape. And in fact, this is exactly the shape that gets made when you throw something and you don't throw it hard enough, so it actually comes back down to wherever you started. However, if I take that same cone, but cut it at a different angle, if I cut more at a slant like this, what you get is that elliptical shape that I mentioned before, which pretty much every planet orbiting around the sun has this kind of shape, same with the comets and asteroids. So it's really one reality, this cone and what we call a conic section, because it's a cut across that shape. That's what unites everything that's under the force of gravity, and I love that this invisible mathematical reality there is driving everything in the universe. This is just one instance of how a single idea is actually underpinning several different realities that are actually joined mathematically. And maths is full of these connections, surprising links between things that look completely different on the outside, but actually the maths under the hood is uniting them. If I had to pick a single key to help students see that mathematics is meaningful, it's that I want students to appreciate mathematics is more than just content and skills. It's not just a bunch of different topics like algebra, trigonometry, calculus. Actually, there's these core skills that run across all of the different parts of maths that are meaningful to you, whoever you are, and what if you're interested in doing in life. Now, we maths teachers call these working mathematically. They're the skills, they're the qualities that we employ every time we solve a maths problem. They're things like communicating, understanding, problem solving, reasoning, and fluency. These are things that matter every single day, whether you're going to go into something super mathematical in your career, like say engineering or finance, but they're also there if you're an artist, if you're trying to write a compelling legal argument. There are points where those mathematical principles and skills are meaningful to you, whatever sphere of life that you're in. So I think focusing on those working mathematically outcomes are really the best way to help a wide variety of students connect to mathematics. In terms of making mathematics meaningful and connecting it to the lives of our students, I think one of the most important things to recognize is that mathematics looks on the surface like it's about symbols and algebra and things like that, formulas that maybe a student might say, when am I ever going to use this in everyday life? But actually, mathematics is really about helping students think in a deductive and a formal and a logical way. And it doesn't matter what problem you're encountering. Actually, all those things that we look at in algebra and geometry and trigonometry, They're just examples that give students kind of a practical context to say, how can you create something that really proves to me in a watertight way, in a convincing way, I'm persuaded that this has to be true. And those truths and falsehoods in mathematics are really powerful to grab a hold of, but they're broadly applied. We want our students to be great thinkers, whatever field they goes into. So I think that if we want maths to be meaningful to students, we want them to recognize it's just about thinking deeply about simple things.